observation system, which is a bunch of tracking equipment that we have out in the lake to track several different species of fish and their movements, and in that way study their behavior. Sorry, I talk really quietly. We have to turn my volume.
Can we have direct access to this stuff?
I'm sorry?
Can we get direct access to this info?
Depends. Okay. All right. So to study movement, we have to track the animals. So how we do that with this technology, we implant each of our fish with an acoustic transmitter. We use a V13s, which are about the size of a AA battery. You put these in the fish. You do a little surgery, sedate them using clove oil, and then once the tag goes in, it sends out a transmission every about 2 minutes. And that transmission is coded with an identification number, so you have each fish is identified as an individual, and that can go back to our data set so we know the sex, the size, where it was released, etc. So these fish, as they're swimming around, when they swim by one of our acoustic receivers, which are the black things scattered throughout this image, if they're within range, then the receiver picks up the transmission, and you have the code of the fish and also the timestamp. So you know which fish is where when. So far we've tagged 15 walleye and 93 lake trout. We're going to tag 11 more walleye this spring. So those are the fish that we have tagged in our system. We have a 27 receiver acoustic telemetry array in Lake Champlain. This is an image. All of the circles and triangles indicate receiver locations. So the lake is relatively long and narrow, which means we can see a good portion of the lake acoustically. So we can see where the fish are all the time. This is different than a lot of Great Lake systems where you have small isolated telemetry systems and you can only see the fish when they're in that area, but we have a really good coverage, so that's why our research is unique to a lot of the telemetry that's going on in the Great Lakes. So we have receivers on all known lake trout spawning sites and also on constriction points in the lake, so we can tell whenever a fish moves from one basin to another. So our two big studies that we have going on right now, one of them is on lake trout spawning behavior, and the other is on walleye interaction with causeways. So the receivers were deployed in two groups. The first group are the light blue receivers, and they went out in October of 2013. And the second group are the dark blue ones, and they went out in August of 2014. So for the first year of the study, we had a smaller number of receivers out, so just keep that in mind when we're looking at the results later on. This kind of got a little mangled. It's okay. So this is an example of the walleye tracking data. So what we have, we're interested in whether or not how the walleye interact with causeways in the lake. So we tagged 15 walleye, half of them up near Swanton Dam and Missisquoi, and the other half down in the main lake near where that green star is. And of these 15 walleye, only one of them actually went through the causeways, so that's what you get for a small sample size. But the one that did move through causeways did really interesting things when he did that. So he was released in October of 2014 down where the green star is, and the line going through is his path of movement. And each of those paths is indicated with dates, so you can see how long each leg of the journey took. So he was released down right off of Burlington, and then within a day had swum through the Island Line Causeway into Mallett's Bay. And then he spent 25 days, or around 25 days in Mallett's Bay, just swimming back and forth from the Island Line Causeway to the Sandbar Causeway. So we saw this type of interaction where it was an approach, some staging behavior where they would kind of swim around the causeway and stay near the receiver for a while, and then turn around and try to find another way out. So it looks to us like the causeways are actually impeding their movement. They can go across them, but it's causing significant delays. So as soon as he got out of Mallett's Bay, he shot all the way up to Isle of Mott in a 24-hour period. And then, so clearly he knew where he wanted to go. He got stuck before. And then when he interacted with that causeway up near Isle of Mott, he was stuck again for another 3 or 4 day period. So every time we see this causeway approach, we end up with a hindrance. So that's just something to think about. This is obviously very preliminary data that we have on these fish. And we're tagging more of them this spring, so hopefully with more fish we'll get more causeway interactions and be able to ask more questions about them. So that's what we have on walleye. But my main focus of my graduate research was on lake trout spawning behavior. So lake trout, obviously, as everyone knows, are native to Lake Champlain. They were extirpated by the 1900s for reasons that are really poorly understood. The historical data just doesn't exist to pinpoint one way or another why they went extinct. So they've been stocked since 1972, and since then there's been no evidence of natural recruitment. So obviously the reproductive behavior is really interesting to researchers because we want to know what's going on. And also, there isn't a lot known about lake trout spawning. Lake trout spawn at a crappy time of year for field work. The weather is always not awesome. And they also spawn at night, so it's hard to see what's going on. So the best way to get insights into their behavior is to track their movement, see where they go, see how long they stay in particular places. So that's what we decided to do. So the three main questions that I was asking in my research, the first one was, are there sex differences in spawning site use? So how do males versus females use spawning sites, and how do they travel throughout the lake? The second question was of spawning site fidelity. So do lake trout return to the same site year after year? And if they do males or females do that preferentially? And the last question is just really monitoring whole lake movements year-round. That's something that isn't done in other lake trout telemetry studies because of the nature of the size of Great Lakes. So we can do that, so we want to see what they do and where they go throughout the year. So the first question, looking at sex differences in site use. So we know that lake trout spawn in lakes, so they're not stream spawning salmonids like many salmonids. Stream spawning salmonids have to go upstream and fight a current, and that takes a lot of energy, so it's very metabolically expensive. So since lake trout don't have to do this, they have this hypothetical energy store that they could be using, allocating towards different behaviors. So we want to know how they use that and ask the question, could they be spawning in multiple locations because they don't have to fight a current? And these spawning sites are patchily distributed, with the lake trout spawning sites throughout Lake Champlain. So from a reproductive behavioral perspective, you have the females with very energy-rich gametes and very few of them. So she's obviously going for quality over quantity. She's going to be looking for a good spawning site, a good group of males, in order to ensure the most survival of her gametes. Males, on the other hand, are looking for quantity over quality because they have a lot of very inexpensive gametes. Doesn't that sound familiar? Yeah, exactly. So it would make sense, we think, that the males would stay put in one spawning site in order to increase their interactions with as many females as possible. Ellen calls this the bar versus the bedroom hypothesis, which is great. So we think that males will probably sit put in one spot in order to increase their number of interactions, because when they're traveling, they're not mating. On the other hand, it makes the most sense for females from a behavioral perspective to travel from site to suss out which one is the best. Where's the good spawning substrate? Are the conditions good? Is there a good group of males? So that's what we think is going to happen. And what we see are male-favored catch ratios on spawning sites. So when you're doing netting studies and you're pulling fish out, you're getting more males and you're getting them earlier in the season, and they stay later than the females do. So this could be because of what we were just talking about, that the males are sitting tight and waiting for females. Alternately, because it's a catch, you're just pulling fish out and counting them, it could also just be that the males are more likely to get into the net. They could be more actively moving around the spawning site, aggressively looking for females, showing signs of other interactions that could make them be caught more often. So in order to figure out what they're actually doing, we have to use telemetry to track their movement. So again, our hypotheses about this sex differences, we think that males will spend more time on spawning sites per day than females. We also think that males will be more likely to show site preference, meaning they pick one site and stay there, as opposed to moving from site to site. And lastly, that females will travel more widely during the spawning season than males will, doing that type of proving behavior, looking at several different sites, trying to find the best one. So the second question is that of spawning site fidelity. We know through marker capture studies that at least there's partial site fidelity with lake trout and other systems. And we think that that will also be evident in our system, with males being more likely to show site fidelity because of this staying put thing. The last thing is just seasonal lake-wide movement patterns. We have a lot of the lake covered, and we have this ability to look at them year-round. So we want to see what type of patterns emerge when we have the ability to look at this data. So getting into methods, our tagging. So in 2013, November of 2013, we tagged 30 lake trout up at Gordon Landing, where that black arrow, well, you guys all know where that is. 30 fish up at Gordon Landing. And then the next year, in 2014, an additional 30 fish. And this is evenly split males and females. So 15, 15, and then next year, 15, 15. Also in 2014, we tagged 33 fish at Whalen Bay in November of 2014, and that was 15 males and 18 females. So we're calling cohort 1 the original 30 fish that got tagged at Gordon Landing because that was the first year, so they've been in the lake for 3 years, so we have 3 years of data on them. And cohort 2 only has 2 years of data because both of these sets of fish were tagged in 2014. So that's how we'll be referring to them in the analysis. So the monitoring period, what we're looking at for the spawning season, we're calling the spawning season October 1st to December 1st based on egg deposition records in Lake Champlain. But obviously the detection period is shorter during tagging years because we go out and catch them in the middle of the spawning season. So for some of this data, it'll be truncated, but that's referred to. So back to the first question, do males spend more days on site than females? And the answer was yes. So just to orient you towards this graph, on the y-axis you have the average number of days for each sex. The blue bars are males and the pink bars are females. The black numbers within each bar are the sample size, so the number of fish that we saw in that particular spawning season. And then across the bottom you have the different cohorts. So first you have the spawning season by year, followed by cohort, and then underneath it tells you if the spawning season was partial or full. So across the board you see the blue bars are higher than the red ones. Yes, males spent an average more days than females did on site. The asterisks indicate statistical significance. So the next question, do males spend more time on site per day than females? So that one was asking throughout the season, are there more days? This one is asking proportion of the day. And the answer was again, yes, males spent more time on site per day than females. So on the y-axis we have average daily detection frequency. So we have a known number of pings we should hear per day. So that number is 720, so then we take the observed number of pings and divide it by that. And that way we get a proportion of the day that the fish have spent on site. And across the board, males again spent more time on site per day than females did, which goes right along with our hypothesis. So that was exciting. The next question, do females travel more widely throughout the lake than males do? And the answer was no. So how we tallied this is every time we saw a fish at one receiver, and then at another one we tallied the distance between those receivers as a total distance traveled, and then averaged them for each sex. And there was no significant difference between the average total distance traveled with males and females. So they're moving about the same amount throughout the lake, which is not what we thought was happening. And then, so that's about movement throughout, and now we're asking, are females less likely to show site preference? Meaning, are they less likely to select one site than males are? And the answer was not really. It looked like both sexes chose a preferred site every year. So they would suss around, look at a couple of different ones, and then pick one and stay at it for more than 50% of their logged recorded time. So this is just an example of one fish and what it looks like, what the data that we're getting looks like to give you an idea of their movement patterns that we're discovering. So across the x-axis we have time, so just in date, and then the number of detections on the y-axis over here. So each bar indicates the number of detections per day, and the color of the bar is a different location. So anytime you see the color change, that means the fish moved. So this particular fish showed he was moving around between Schuyler and Gordon Landing, Schuyler Point and Gordon Landing, in the beginning of the spawning season, moving around, looking at different spawning areas, and then found the one that he liked down at Whalen and stayed there for the duration. So that was a pattern that we saw with a lot of the fish. There was an investigatory pre-period followed by a site-preferred period. And that was for both males and females. So there's no difference in lake-wide movement. So that kind of blows our idea out of the water that females are swimming around and males are staying put. But we thought, well, beyond looking at different areas of the lake, what if there's a difference in behavior once they're actually on the spawning site? So once these fish get there, are the males and females doing something different? So what we did is we put a couple of extra receivers around one of our main spawning sites where we tagged the biggest number of fish. And what we were doing is we're looking at the proportional amount of time that fish spent at the site center versus the amount of time they spent wandering around the general area. And we wanted to see if there's a difference between males and females in how much time they spent wandering versus staying stationary in the middle. And we found that females were less loyal to site center. So they were actually moving a little bit, not significantly so, but across the board, they were moving more than males were. So they were staying in the middle less. So what that tells us is that that might account for the fact that we're seeing less females come into the nets because they're not really staying in the middle. It's possible that these males are staying in a tight group and swarming around, and then females are coming in, selecting a male, performing the mating act, and then getting the hell out of there, because why would they want to be harassed all day? Seriously. So that's what we're finding with that. And the last question is there a difference in spawning site fidelity between the sexes? And the answer was no. So across the board, we have females and on the that side, I don't know my left from right, and males over here. We have sample size inside of the bars, and the proportion of fish is up on the y-axis. So fish that showed site fidelity, it was 65, around 55 of the females, 55% of them, and around 75% of the males showed site fidelity. But that means that the rest of them didn't. So we're actually seeing a significant number of fish that are straying. And by straying, we mean when we see fish multiple years in a row, they're showing up and preferring different sites more often than we thought. So Ellen and I thought this was going to be around like 90% for both. And we're actually seeing a lot more straying. So that's kind of exciting, and we're hoping to do more with that idea and look more into questions like that in the future. And the last bit is we're starting to monitor year-round lake-wide movement. So what this figure is showing is the average total distance traveled throughout the year, not just the spawning season. And obviously you see that big peak at the approach of the spawning season. The fish are swimming around a lot looking for a spot to spawn. You see a big lull in the winter when things are really cold, and it starts to pick back up in the spring when fish are starting to feed again. So yeah, some interesting things that we're figuring out. This is all very preliminary. We were really focused on the spawning stuff, but it's exciting that we have this huge wealth of data, 3 years of fish movement 24/7, and we can ask a lot more questions with it, and excited to see what comes out. So in conclusion, we found that males spend more time on site than females. Females do not travel more throughout the lake, but they are less loyal to site center. So you're seeing on-site differences in spawning behavior. 60 to 75% of all fish do show spawning site fidelity, and we're monitoring whole lake movement patterns. So thanks to our captain and deckhands and you guys for listening.
I can't imagine, Tori, it won't generate questions.
I'm sorry?
You said there are no naturally occurring lake trout in the lake?
Very few.
Very few.
Very few.
Because I've been out on the Melrose Syro when we actually saw one.
Yes, so this year, actually, Ellen is kind of working on a project right now. Steve Cluett, who's our amazing captain, has started trawling aggressively, looking for naturally recruited lake trout, and they've actually found quite a few this year, more than they've ever found before. And they're doing gut content analysis on those fish and finding that they are actually eating things different than the hatchery-raised juveniles. So just some interesting differentiations there. I can't comment on it, it's not my project, but it's cool, and maybe next year we'll have something to show you guys. Yeah, for sure.
They just don't make it from, small to large. They don't make it to adulthood.
Right, right.
So there is naturally reoccurring, but they're just not in great numbers. They don't know why, but they don't make it to adulthood.
Yeah, exactly. But still, this year we're finding more than we ever have, and it maybe is because we're now looking in the right place. So.
Super.
Yes.
I got a lake trout. How would I know it's a natural?
If it's a natural, it'll have no fin clips.
No.
No fin clips, right. So a hatchery-raised fish will have a fin clip. A very, very small percentage of them don't. But if you find one with no clips, then it's a naturally occurring fish. And you should be super psyched about that.
Hey, Tori?
Yes.
How will we identify what fish have it?
Oh, yes, I should have opened with that.
And should we release them and get you information, or what?
Yes. So all of my fish that have transmitters in them have external FOI tags as well. And these FOI tags have an email address. So if you find one of these fish, please let it go if it's okay. And then send us an email and we'll actually send back a $50 reward for that information.
What's the tag look like?
The tag is a green spaghetti tag right under the dorsal. But if you do catch a fish that has a transmitter in it that's untagged, we would love for you to get in touch with us too, just to let us know that that fish is now out of the system. But most of them have externals on them, so.
Why would they be without a tag?
They can come out sometimes, foys aren't awesome, and when we're in the process of releasing the fish, we see a lot of them kick them off within 5 minutes, so. Yes,
What kind of mortality rate did you see in tag fish? Did you keep them all, or did you lose a certain percentage?
that's a solid question. So the first year of surgeries, we lost for sure 1 fish. The only way to know if we lost a fish definitely is if you see that fish dead in the system. So if it dies near a receiver, it'll be pinging constantly. And if it pings constantly for a period of more than 2 months, we pronounce it dead. But if we just never see the fish again, it's very possible that it's just outside of our system. So it's kind of hard to tell mortality unless you have a fish that died directly in our system. And we only had 1 so far that did, so 1 out of 100 something, not too bad. If anybody needs small surgery or stitches, I got you.
Are the walleyes tagged the same?
Yes, yep, they're tagged the same way, and they have the same foy tags on the back as well.
So for minor stomach surgery, you're the person to see?
Oh, yeah.
As long as you have scales.
For sure.
So Tori, there's like 90 fish swimming around that still have these transmitters.
93 trout and 15 walleye. And also 10 lake sturgeon. The state tagged 10 lake sturgeon, which are mostly in the rivers, but we're getting them in our system a little bit too, which is cool. So. Yes.
What happens if one of the fish you do catch, when they do die, you can't really turn it back, what do you want done with that?
Oh, totally, still email me and we'll still give you the reward, and then also we'll come pick the tag up from you. Because if it's young enough, if the tag has only been in for years, that we can just pop in another fish. So each of the tags that we put in these fish are $350, so we really want them back. Yes.
I assume that if lake trout is not fin clipped, that it is a natural, is that
Yes,
okay?
almost all the time. There's a very small percentage of fin clip error where like at the hatchery they might miss a trout every I think it's 1 or 2% error or something like that. But on average, if you find a fish with no clips, it's natural.
Okay, we picked one up last year, about 5 pounds.
Oh, 5 pounds, wow. That's incredible, I'll have to tell Ellen.
Last year, I actually sent Ellen an email because we did catch one of the fish with her tag in it.
Oh, yeah?
And I don't know if you knew anything about that.
Did she not get back to you?
Oh, yeah, she got back to me.
Oh,
She said
nice.
it was definitely one of her fish, but I haven't talked to her to know if there was anything else at the fish.
Oh, you caught and released it?
Yeah.
Yes, I have that, yeah, I know that one. 26892.
Was there any other ones caught before?
Yeah, we had one fish caught, and they killed it, so it died. So we got the tag back from them, and the guy got his reward, he was pretty excited about it. Yeah, so. Yes,
When you talked about site loyalty.
Yeah, to the site center.
Between years, no, between years.
Oh, okay, yeah.
That fidelity
Yep.
to come back. You said you expected around 90% just as a hypothesis. Is that because there have been other studies done that have shown in natural populations that's the case? I guess I'm wondering about imprinting. So if these are hatchery fish,
Right,
that are put in, have they already missed the window that they would have imprinted? So
right.
that they're just, moving around to try to find other fish to spawn or?
Yeah, well, the marker capture studies looking at fidelity that we saw had slightly higher rates than we had, but still not full fidelity. It was always in the 70% area. But yeah, it just certainly could be the effect of them being hatchery raised. Unfortunately, we don't have any naturals big enough to tag, but hopefully one day we would, and then we could see what the difference was. Yes?
Is there a way that we would be able at some point to be able to track individual fish?
That is sort of in the works. So we have our website on the UVM website outlining basically this whole project, and there's a section there that you can go to report a fish if you find one. And we're trying to develop a program where if you report a fish we'll get back to you, like we'll send data back to you on that fish, like where it went, kind of like an adoptive fish program. But we don't have the raw data out on, obviously, the raw data out for the
So if we
taking.
wanted to see Lake Trout number 42, where he is.
Right.
Where he's traveled.
Yeah, I mean, I could tell you.
I know you should. Is there a way we could access this on?
Not right now. The best way to access this, right, we're also on the GLaDOS website, so the Great Lakes Acoustic Telemetry Observation System. If you go on that site, there's a map of our receivers, and we're in the process of getting some of our data up there too. So if anybody is interested, you can go to that location.
No, Bill, no, Bill.
Yes.
You mentioned that you were studying the impact of barriers on the walleye.
Yes.
Did you notice anything similar with the lake trout that you had monitored as well?
We haven't done that analysis yet, but that's coming up for sure. We wanted to do walleye because they're cool water instead of cold water, so they're more likely to move through those barriers that might, because obviously the causeway breaks are very shallow, so especially in the warmer seasons, that water will be really warm. So it's unlikely that a lake trout would pass through. So we thought that a walleye would be a better species for that type of study, but since we have the data, we're certainly gonna ask that question. Yeah, that's in the works. Yes?
That walleye that traveled that distance in 24 hours, is that normal or is that?
We are seeing that, yeah, we have lake trout that travel that distance and then some in 24 hours as well. So it's like, they're actually cruising around the lake during spawning season.
I got a feeling.
Cool, thank you guys so much for your time. Thank you.
Thanks, Tori, great presentation. Here's the man, turn it over to Dean.
Hi, guys. So what we're gonna do this year, a little different, is we're gonna take the break right now, stretch your legs, get a water, whatever you're gonna do. Then we're gonna give out the raffle prizes, and then we're gonna bring up Matt Trombley. And he's gonna teach us all how to catch more fish. So take a little breather, stretch your legs a little bit, and then we'll do the raffle and we'll get Matt up here.